is given by capital M. Capital M is equal to M11, means minor of A11 is M11, minor of A12 is M12. Like you have to find all minors. So 21, M22, M23. So M31, M32, M33. Okay. After finding all minors of a matrix, then you can find cofactor of a matrix. So cofactor of a matrix, I'm taking as capital C. Capital C is equal to cofactors of each and every element, that is C11, C12, C13, C21. Second row, first column. Second row, second column element. Second row, third column element. So C31, C32, C33. Okay, fine. After finding this, so where here, remember that where Cij is equal to -1 all to the power of I plus j of Mij. This is the formula for finding cofactors. So once you get minors of the given matrix, after finding minors, to find cofactors, you should use this formula, right? Cij, the element which is belongs to ith row, jth column is clearly equal to -1 all to the power of I plus j Mij. If you take I is equal to 1, j is equal to 1, we'll get C11. Substitute I is equal to 1, j is equal to 1, we'll get C11, that is equal to -1 all to the power of I plus j, that is 1 plus 1, M11. So after finding this a cofactor matrix, then adjoint of A is clearly equal to transpose of the cofactor matrix. Just interchange the rows and columns of cofactor matrix, will get adjoint of A. So after getting this matrix, you have to substitute here. Okay, you have to substitute here. So A inverse is equal to 1 by dt into adjoint of A. 1 by dt into adjoint of A. Am I right? So first we have to find the determinant. If determinant is non-zero, then only A inverse exists. In case determinant is 0, that we know that 1 by 0, 1 by 0 nothing but undefined. Okay, so that is infinity, infinity. So A inverse should not be infinity. So A inverse also should be 3 by 3. If the matrix is a 3 by 3 square matrix, A inverse also must be 3 by 3 alone, right? And can we find the inverse of a matrix for non-square matrices? Non-square, like the order is 2 by 3, 3 by 2, 4 by 5, like that. Is it possible to find inverse of a rectangular matrix? Anyone? That's not possible. Am I right? Okay, we cannot find inverse of a matrix because that is not exist for non-square matrices. So determinant is possible for only square matrix, right? Fine. So that you know very well, you should note it down. Okay, let's find the minors, then we can find cofactors, then we can find adjoint of A. Like you can go through like these steps in NCRT. Okay, if they give for 5 marks, so you should write the minor of a matrix, cofactor of a matrix, then after adjoint of a matrix, then A inverse is equal to 1 by dt into adjoint of A, right? So here we can cover 3 exercises. 3.1, which is belongs to determinant, determinant. 3.4, 3.4 exercise. So that is belongs to minors and cofactors, cofactors. Then sorry, 3.4 is which is belongs to minus and cofactor. 3.5, 3.5 which is belongs to adjoint of A and inverse, adjoint and inverse, right? Okay, let us find first minors of a matrix, then cofactors. Okay, step by step. This is question number clearly 8. Let us take the given matrix as capital A, that is same 1, 0, 0, double 3, 0, 5, 2, minus 1, 5, 2, minus 1. Okay, right. Find minus of a matrix. That we know that the minors of a matrix is M11, M12, M13, so on. Okay. No, otherwise I'll give. Otherwise, have you taken? Okay, 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 no problem. Right, friends. Now find minors. Now you should write like this: minor of an element. For the first element, one is M11. So one is belongs to first row, first column, right? I already told you that if possible you can comparing with A11 like that, A11, A12, A13, like that you can write all elements, right? M11 is equal to, so a minor of A, like M11 means, so eliminate or delete this first row and first column, the determinant of submatrix. So what is the mean by submatrix? So eliminating some rows and columns, otherwise only row also. You can eliminate or rows or columns or both, then the resultant matrix is called submatrix. Okay, here once deleting this first row and first column, we get a submatrix. So what is the submatrix? 3, 0, 2, 1. You have to find the determinant of this submatrix, right? 3, 0, 2, minus 1. I hope that everyone got idea about how to find um, the inverse of a matrix. Anyhow, it is very important. We'll do one more problem, right? Already we have done each and uh, last class one problem, right? M11. So what about the result here? This result is what? This is equal to what? AD, AD minus BC. 3 into minus 1 minus 3 minus 2 into 0 0. So this is minus 3. So finally, minor of an element 1 is M11. So in the same way, similarly, minor of what is the second element? 0 is 0, which is belongs to first row, second column. That is nothing but M12. M12 is equal to, yeah, except this first row and second column, because 0 belongs first row, then remaining is 3, 0, 5 minus 1, that is equal to minus 3. Am I right? 3, 5, 3, 5, 0 minus 1. Then the same way, the minor of another 0 is M13 is clearly equal to again the determinant. So other than this row and column, first row and third column remaining 3, 3, 5, 2. 3, 3, 5, 2, again AD minus BC. 3 to the 6 minus 15. 6 minus 15 is clearly equal to minus 9. Am I right? So in the same way, minor of the second row first column element is 3 is M21. M21 is equal to again the dead tab. So delete this second row first column remaining 0, 0, 2 minus 0, 0, 2 minus 1. This is equal to 0, right? In the same way, minor of this next element 3 is, that is M22. So this 3 is belongs to second row, second column. 1, 0, 5 minus 1. So 1, 0, 5 minus 1. This is equal to minus 1. Am I right? Okay. Then next, minor of minor of yes or no? Minor of next element is 0. Yeah, what is the answer? Can anyone got the answer? Okay. So then 0, which is belongs to second row. So you have to eliminate. So remaining is 1052. 1052, that is equal to 2. Is it clear? 1052. Right. Next, the minor of next one is so what is the minor of next 5? Minor of an element 5 is so 5 which is belongs to third row first column, that is M31 third row first column. Then det. So if we eliminate or delete this third row and first column 0 0 3 0 0 0 3 0, nothing but 0, nothing but 0. In the same way, minor of 2 is M32 M32. So 2 belongs to third row second column 1030 1030, that is 0. Next, minor of at last minor of minus 1 is that is belongs to third row third column. Then other than this third row third column 1033 1033. So you are finding minors is very important. You should find very carefully. If any one of the value is wrong, then we need to find cofactor of that matrix, that is also becomes wrong. Finally inverse of a matrix becomes wrong, right? So minor of this is 1, 1 into 3 3 minus 0, so that is 3. AD minus BC. Okay, fine. So we got the minus of all matrix. Then what is the minus of a matrix? Capital M is equal to, yeah, substitute all values like minus 3, minus 3, minus 3, minus 9, 0, minus 1, 2, 0, 0, 3. Is it right? Minus of a matrix. I got this minus of a matrix. Is it correct? Next, cofactors. Cofactor of a matrix. So cofactor of a matrix depending on this minor of a matrix. So first you have to find like cofactor cofactor of M11 is C11, that is equal to minus 1 whole power. I said very clearly Cij. Cij is equal to minus 1 whole to the power of I plus j, nothing but here what is I nothing but row, what is a column 1. So into first element already we know that minus 3. So this is equal to what? This is clearly equal to minus 1 whole square. So that is plus 1 into minus 3 minus 3. So C11 is minus 3. So next cofactor of instead of this M11 you can take the value 1. So cofactor of next element is 0. 0 is C11. C12, sorry, C12 is equal to minus 1 whole to the power of 1 plus 2 M12, that is equal to minus 1 into M12 value. M12 is minus 3, right? So this is clearly equal to what? 3. In the same way, everyone find all cofactors. Like what is the cofactor of the third element 0? Is that is belongs to C13, first row, third column, minus 1 whole power 1 plus 3, M13, that is equal to 1 into M13. M13 is minus 9, that is equal to minus 9. Okay, next, the cofactor of 3, cofactor of the element of an element 3 is, this is belongs to second row, first column, C21, minus 1 whole power 1 plus 2 plus 1, M21, minus 1 whole power to minus 1 into M21. M21 is 0, that is equal to 0. So here, whatever the elements are 0, so cofactor of this three zeros also becomes 0 as it is. 0 alone, right? So your sign will be changed, plus, minus, plus, minus, plus, minus, plus, minus, plus, actually. Okay, but we should not write directly in NCRT. You should write the steps. So like that you should write. So next, then next step, 3 is, this 3 is belongs to, that is C22 is equal to minus 1 whole power 2 plus 2 M22, that is equal to minus 1 whole power 2 plus 2 means minus 1 whole to the power of 4, that is plus 1 into minus 1 is equal to minus 1. So in the same way, the last element 0, 0 is, this 0 is belongs to third row, second row, and third column, minus 1 whole power 2 plus 3. So this is equal to like M23, that is equal to minus 1 into, so whatever the value here, 2, minus 2. This is minus 2. Okay, minus 2. Then remaining cofactors. So we need to find 3 more cofactors. So cofactors of 5 is C31. This is equal to minus 1 whole power 3 plus 1 M31. M31. Okay. Clear? M31. So C31 is equal to, this will 3 plus 1 4, that is plus 1, because minus 1 whole to the power of 4 even power becomes plus 1, and M31 is 0. This is clearly 0. Then cofactor of this is already 0, minus 2 is, that is C 3 2, also clearly 0. Yes or no? 0 into anything 0. Finally, the cofactor of the last element minus 1 is C33 is equal to minus 1 whole to the power of 3 plus 3 M33. So that is clearly equal to minus 1 whole to the power of 6, that is plus 1, M33 is 3, so that is equal to 3. So we got all cofactors. Then we have to write cofactor matrix, that is capital C is equal to C11, C12, like all cofactors you can write. So the cofactors are first minus 3, next 3, next minus 9, then 0 minus 1, minus 2, here 0 0 0 0 3. So these three zeros are common, right? See here, simple. What is the answer we are going to get? Here, when you keep like this, plus, minus, plus, minus, plus, minus, plus, minus, plus. See here, plus into minus 3, minus 3. Minus into minus 3, plus 3. And plus into minus 9, minus 9. 0, anything, zeros, anyhow, zeros only. And remaining is plus into minus 1, minus 1. Minus into plus minus 2, 0 0 plus into 3 plus 3. Okay, plus into 3 is plus 3. Like that. So after finding this, what about adjoint of a? Students, adjoint of a. So adjoint of a is equal to c to the power of t, transpose of a given matrix. What is the transpose here? Adjoint of a is clearly equal to, right, first column you can write as first row, second column 3 minus 1 0, and minus 9 minus 2 3. That is adjoint. Okay, actually the first step we need to find the det we know how to find the determinant of a matrix. Okay, so that I found first adjoint of a, right? This is the adjoint of a given matrix finally. Okay, so first find all minors, then after you can find their cofactors, then cofactor matrix adjoint. Then, so all of you find what is the det. If you're having any doubts, you can ask.
So det is minus 3, sir.
Yes,
Det is minus 3, sir.
that is minus 3. Huh? Okay, let's see here. See, determinant, to find the determinant, there is a shortcut way. That is, if we use, I said that how many ways we can find the determinant of a 3 by 3 matrix? How many ways? 6 ways. 6 ways we can find. Either you can use the first row or second row or third row, 3 methods, 3 ways. And first column or second column or third column, 3 ways. Totally in 6 ways we get the determinant of a matrix. Okay, determinant of a matrix in the sense. So we know that the cofactors I compared with A11, A12, A13. If I want to use the first row, if I want to use the first row to find the det A, determinant of A is given by determinant of A, det A is given by A11. I'm using just first row. A11, their corresponding cofactor. C11. A12, C12 plus A13, C13. Right? Okay, like this, we can find the determinant. Already we know that the cofactors. This is C11, C12, C13. Nothing but the sum of the, see, sum of the product of elements and its cofactors is give determinant. So the sum of the product of the elements and its corresponding cofactors will give determinant of a matrix. Let us see here. A11. What is A11? 1 into what is the corresponding cofactor? Minus 3. So minus 3 plus A12, that is 0. 0 into its cofactor. Anyhow, 0 into that value becomes 0, and the 0 into cofactor minus 9. So this is clearly equal to minus 3. Okay, this is the first way. Second way, let us see second way. Determinant, I want to find the det A by using second row. Second row. What is the second row? A21. What is the corresponding cofactor C21? A22, C22, A23, C23. Like that. Okay. Now A21 second row 3 into their corresponding like 0. A22 3 into C22 minus 1. Okay, A23 is 0. 0 into C23. C23 is minus 2. So what is the result? Again minus 3. See here, minus 3, minus 3. Even you can use the third row and its cofactors. You will get minus 3 alone. In the same, you can use the first column. First column, like I want to use the first column A11, A21, A231. Then I want to find the determinant, will get the same answer. Okay, let us see any column you can take. So you let us find. Okay, I want to take the third column. Let's see here. Third column. I want to use the third column. Then I want to find the determinant. So that is the third column is A13, C13, A23, C23. So A33, C33. So let us substitute the values here. 0, 0 into its cofactor plus 0 into its cofactor. Any of first two are 0. Then what is the third? Minus 1. Minus 1 into C. C33. Yeah, 3. Actually, here 0 into minus 9 minus 2. So what is the resultant here? 0 into 0, 0 minus 1 minus 3. See? So all the cases will get the determinant is same. Okay? Like that, we have to find the determinant of a matrix. You can use any row, any column according to your convenience. Your convenience, right? Okay, anyhow, we got the determinant and we got the adjoint. Adjoint. Then inverse of a matrix. Therefore, we have tried the formula. Therefore, the inverse inverse of a matrix capital A is A inverse is equal to 1 by dt into adjoint of A, right? So A inverse is equal to 1 by minus 3 times of adjoint of A. What is adjoint of A? Minus 3, 0, 0, 3, minus 1, 0, and minus 9, minus 2, 3, right? So multiply with this. So, right. First, minus 3 by minus 3, 1, 0, 0. And this is also clearly 0. Then 3 by 3, 1. This is clearly minus 1, sorry. 3 by minus 3, minus 1. So 1 by 3. Then this is clearly 3. This is clearly 2 by 3. This is clearly minus 1. This is A inverse. Is it right? Is it right answer? Once check that book back answer. But very, very important, finding inverse of a matrix. Right?
Correct, sir.
How many of you completed this question number 11 in exercise 4.5? So I am observing that few students are regularly absent. I don't know why. And Nearly 10 students, they joined the meeting very late. Okay. Question number 11, you have to try. So, what is the determinant of question number 11? Anyone? Determinant.
-2.
Determinant of question number 11, 1, 0, 0,
-1.
0,
Minus
0 cos alpha. Is it minus 1? 1 into minus cos square minus sin square. Right, minus 1 is right. Date of question number 11 is. So that date you can try. Let's do that question number 12. They given one property inverse of a matrix AB, all inverse is equal to B inverse A inverse. That is one of the important property, right? So if you complete it, I'll go for the next question.
sir, break is there, sir.
Sorry.
The break is there, sir.